Hello and welcome to my channel Mathematics Applied. Once again, I am here with the last part of application of integrals, part 3b, where I am going to solve a few problems so that you understand how to solve such problems of this part of the syllabus, application of integrals. So let's go with the first problem. Find the area of the region bounded by the ellipse x square by 16 plus y square by 9 equals 1. So I'll rewrite the equation because they have given the name ellipse. So you need not panic. Now you know that this is an ellipse. So you just write here, rewrite the equation with the actual format. So this is 16 means 4 square plus y square by 3 square equals 1. So here I understand that a is equal to 4 and b is equal to 3. So I will draw the graph for this. So I have the y axis, the x axis, and I mark 4 over here and I mark 3. Right, roughly I will mark 3 and I will draw the graph. A smooth curve you have to draw. Okay, this is the ellipse that is required. So this point is 4 and this point is 0. This point is minus 4. This is 3 and this is minus 3. Now you are asked to find the region bounded by the ellipse. Region bounded by the ellipse means you have to find the area of this whole region. Right? How can you solve this? Now you can integrate this curve from this point to this point. You integrate. So you will get this region, right? Upper side region you will get, and that you can double. That is one way of solving it. That is, you integrate y form of the curve from, with respect to x, from minus 4 to plus 4. This is one way of doing it. Another way of doing it is only take this part of the curve and integrate. So you will get the area of this part of the curve, area of this region, right? 1/4 of the whole region you will get. So this you can multiply by 4 and you can write. So you write area bounded by the ellipse is equal to 4 times integral of this curve in the form of y. So we will write this in the form of y. Y equals, it is 3 by 4 root over 16 minus x square. So you write that here, 3 by 4 root over 16 minus x square dx from 0 to 4. This is what we are integrating, from 0 to 4 on the x axis. So that is equal to 4 times 3 by 4 times the integration of root over a square minus x square, that is x by 2 root over 16 minus x square plus a square, that is 16 by 2 sine inverse x by a is 4. So from 0 to 4 you apply this, this limit you apply, and you get 3 times this is going to be 4 by 2, that gives you 2, but here if you apply 4, this gives you 0. So first term is going to be 0 and the second one is going to be 8 times plus 8 times sine inverse 4 by 4, that is 1, minus, now you have to apply 0. When you apply 0 here, this is going to become 0, right? And this is also going to be sine inverse 0 is 0. So 0 plus 0. Ultimately your result is going to be 3 times 8 into sine inverse 1. Sine inverse 1 is pi by 2, because sine 90 is 1. So therefore this is 4 and you have 2 pi square units. This is going to be the area bounded by the ellipse. So you just report your answer as the area of the bounded space within the ellipse is going to be 12 pi square units. So here is the next problem, that is find the area of the region bounded by y square equals 9x. So there is one equation. Then x equals 2, x equals 4 and the x-axis in the first quadrant. So this is one curve, this is another curve, another curve, another curve. So we will draw the curve first. This is x equals 2. So let's take 2 over here, 4 over here. Let's say that is the point. And the curve is going to be x equals 2 is a straight line which is parallel to y axis, and another line which is again parallel to y axis but at x equal to 4. So this is 2. So these are the two lines, right? Now this is point 0. Now we will take y square equals 9x. This we can convert as two forms it will have. So you can either write one of them, right, depending upon what is required. I am writing both of them. Y equals 3 root x and x equals y square by 9. Now we would require any one of them, because depending upon what method we are going to, with what axis we are going to integrate. So here when you have x equals 0, this gives me y equals 0. And x equal to 2 gives me y equals 2 times 9 and root over that, so 3 root 2. And x equals 4 gives me 9 into 4, root over that is equal to 3 into 2, that is 6. So these 2 points are definitely required for us, because we want to know where that is cutting. Just to be very clear in what that region is going to be. So that region has to be very clearly shown. So that's why we are finding out the value of y. Therefore, this is 2. So here we will mark 2 and here we will mark 4, and another one we will mark 6 over here. Right? So here the 6, and this side also 2, 4, 6. So this 3 root 2 is slightly greater than 4. So we will take 4 and mark some point here. This point symmetric to that, this side, one point, and 6 is the next point. Here we will mark, and here we will mark, right here, and smoothen this curve. So this is the x equals y square equals 9x. So what region we are looking for? They are asking the region which is bounded by x equals 4, x equals 2, the curve y square equals 9x, and x axis, this axis. So this is the region which is required to be found. So we have to find this, and with x axis it is straight away this curve is forming with the x-axis. So the curve that we are going to choose is this one. So we will say a bounded area is equal to integral of y dx with respect to x, because it is making with x-axis, and from point 2 to 4. So that's it. Now we can solve this one. So here is the solution. That is, the area of the region is coming out to be 16 minus 4 root 2 square units. So here is the next problem. The area between x equals y square and x equals 4 is divided into equal parts by the line x equals a. Find the value of a. Now there is an area between x equals y square and x equals 4. So these are the boundaries. You understand? X equals y square and x equals 4. So we have the y axis, this is the x axis, and since this equation is x equals y square, that means this is y square equals x, and this is again open on the right side. So roughly we will draw because the points that are there, on the rough side you can just work out. X equals 1 gives us y equals 1, and x equals 2 gives us y equals root 2, right? So that graph is, we can mark. So here is, let's say, 1 and here is 2. So here is 1 and here is 2. This is open on the right side. So this curve we can draw x equals 1 and y equals 1. This is 1 point. For x equals 2, this is not 2 but it is root 2. Root 2 is 1.414 somewhere here. So this is going to be this point. So symmetrically you draw 1 point, mark 1 point this side and mark another point this side, and you can smoothen you can draw the curve, a smooth curve you can draw that comes to this point and then goes this way. So this is the curve, right? Next we have x equals 4. This is 2, and we should take another 2 values to the right, and we have 4 here. So we mark x equals 4 this side. So this is the boundary, that is the boundary. Now this is divided into 2 equal parts by the line x equals a. So somewhere here you will draw a line which will be somewhere here. So this is, let's say, a. We do not know what that is. Okay, this is roughly we have drawn, because this side it is going to be slightly bigger because it is going little expanding. So therefore this side area should be equal to this side. Therefore what I have done is I have taken it little right side to 2. So this region should be equal to this region, right? This is a and this should also be a. So this is how this is. Now we have to find what this is. Now how are we going to solve? One thing what we can do is, you find the area of this curve. Under this curve you find the area, right? Because this is symmetric to this. This area is symmetric to this region. Therefore, you can just integrate this from this point to this point, this point to this point, and get the area. And from this point to this point, you integrate, you get the area, right? So both the areas should be equal. You can equate them and find the value of a. That is one way of doing it. Another way of doing it is, integrate this part from 0 to a. You integrate what it should be. It should be equal to half of the area of this whole curve from 0 to 4. Half of this. So we will integrate the y of that. That is root x dx. Y means root x. So from 0 to a we integrate, and that should be equal to integral of half of, that is half of integral of root x dx from 0 to 4. By the problem we have written this, right? Because the problem is telling us like this. So this is half of this. Now we will solve this and get the value of a. So this is on the right side. You have root over x means x power 3 by 2. So this is from 0 to 4. On the left side you have integral of, this is from 0 to a. So this gives me, on the left side this is so, and on the right side this is half of x power 3 by 2 and 4 to 0. So after solving, we get this. A is equal to 4 power 2 by 3. You can pause the video, you can see how it is being solved. Here is another problem. Find the area bounded by the parabola y equals x square and y equals mod x. So here y equals x square means this is a they have given the name also parabola. So you need not panic, this equation is referring to a parabola. Now what you have to know is how to draw this parabola and how there it is, like it is open on the upper side, on the upper y axis. So you will draw this curve. This is y equals x square, which is open on the upper side, and y equals mod x is a V-shaped curve, which because here there is x, so therefore it will touch the x axis at 0. Right? So we will draw the curve. So this is how the curve is going to be, y equals x square. So I have found the points where it is going through by solving, values, keeping the values for this. So this is the curve, and sorry for that one because there was a power cut. So here this is the curve y equals x square. If I solve this, this is a simple one, x equals 0, x equals 1, x equals 2. If I apply, I get values for y. So this is y equals 4. So this curve is going to pass through 2, 4. So this is 2 and this is 4. It passes through 1, 1. And this y equals mod x. As you know, x equals minus 1. This is one curve that we already know from 11th standard. So x equals minus 1 means y is equal to 1. So this is also going to be, it's a V-shaped line which is going to be in this. So what is the region that we are required to find out? This is the region we are required to find. This region, right? He says area bounded by the parabola this and this. So on both sides you have. So these two regions you have to find, put together. What you can do is you can find the area of this region and double it because both of them are symmetric. So we can solve this by, if you look at this problem, this is area bounded by two curves put together. One is a line. It is not one curve with another, curve which is not a line, right? So this is line and curve, between line and curve. So that's why I have taken this problem. Now how can I solve this? If I take this x-axis as the, my boundary, so with x-axis if I am going to integrate, then I have to integrate the line first. So I will get this whole area, and then I will integrate this curve. Below this curve I will get this area again. I will subtract that area from the lines area, from the line area. So actually what is that area bounded, or bounded area I must write, should be equal to integral of the line with respect to x. The line with respect to x from what point? This is 1.0 and this is 1. So 0 to 1, because these two curves automatically cut at x equals 1. So therefore, it is already known from that. So therefore we write, no need to solve this. You can get this point by when you draw the curve. You get that point. Okay, if you have a confusion, then you must understand that parabola will go like this. So it is not going to go this way. It's not going to go straight. This is a straight line. Parabola will go a little lower than that. So therefore automatically this is going to be line integral minus, you subtract the curve. You integrate the curve with respect to x, integrate it from 0 to 1 and subtract it from the line. So we solve that further. So it was integral of line minus integral of curve, right? As I said, it is integral of line minus integral of curve, but it has to be doubled. That I forgot to tell you. That is into 2 we will multiply. So we find that line is actually x dx, because on the right side it is going to be y equals x. So therefore x, and this is going to be x square because y is equal to x square. So we have this multiplied by 2, and that's it. When we evaluate, that is coming out to be 1 by 3 square units. So let's go to the next problem. Let's take another problem, and let this be the last problem. Find the area bounded by the curve x square equals 4y and the line x equals 4y minus 2. So what they have written here is, they have said it is a curve. So they have not said what this curve is. Now as soon as you see this curve, you must understand that this is a parabola. You must recognize that. That is x power is 2 and y power is 1. So therefore this is a parabola which is open on the upper side, right? So that is the parabola, and x equals 4y. This is a line which is inclined to both the axes x and y. Now we have to draw this curve. So let us draw this curve first. X square equals 4y. Let us draw that. I hope you would have tried drawing this. I paused the video and I tried to draw this. So what I did is, I take x equals 1. Here I put x equals 1, and I get y equals, so I found those points which satisfies this curve. X equals 1 means y is equal to 1 by 4, and x equal to 2 gives me y equal to 1. So I have taken those 2 points, x equal to 1 and 1 by 4. Okay, so this is going to be my 1. So this point is going to be 1. So therefore, I have taken, this point is 1. So therefore, for 1 it is 1 by 4. So this is 1 point, and for 2 it is 1. So therefore, I have taken this 1. So this is actually 1, right? And this point is 1 by 4. So by just plotting those 2 points and this side symmetrically 2 points, I have drawn this which looks like a dish, right? So this is the parabola. Now we have to find this line, right? We have to draw this line. What I have told in my previous part of the video is that for inclined line, what you have to do is put x equal to 0, and you find out what are the y and x intercept. Y intercept is going to be, when you put x equals 0, this y gives you 2 by 4, that is 1 by 2. And put y equal to 0, and that gives me x equals minus 2. X equals minus 2. So I will take point, accordingly, x equals minus 2, this is 1 point, and y equals half. So this is another point. So I will take these 2 points and I connect this by using a scale. So now you can see I have drawn this line, and you can see that this line is cutting this curve at 2 points, and the region that is area bounded, that region is actually this one. This is the region, right? Now how are we going to find this area? We could find this about the x-axis or about the y-axis. In any case, we require, if we have to do it, let me explain. When you have to find it with y-axis, what are the complications that are there? You can go through those complications first. See this side, about y-axis, there is one part this side, and there is one part this side, right? So you have to take them separately and handle them separately and find out what the area is. Now what you could do is, about the y-axis, you draw a line this side. So you have a point here, integrate this curve with respect to y-axis, so you will get this area, and integrate this curve with respect to y-axis, you will get this area. And again, this side, that is one part of the area, and then integrate this portion of the curve about y-axis from this point to this point, and then integrate this line from this point to this point, subtract that. This will give you, you will drop a line here. Actually, what is this point? We must know what this point is. So for that, what we have to do is, I forgot to tell you that when you have to integrate from this point to this point, that means you should know what this point is, right? So how do we find that? I will tell you that, but first let us understand how we will find this area. This curve is integrated about the y-axis, so you will get the whole region, and then integrate this line about about the y-axis from this point to this point, you will get this triangle's area. Subtract that from the previous one, so you will get this region. Then add that with these two areas that you receive. So many complications are there for the y part. Now look at the x direction. In the x-axis, if you have to find, you just have to integrate this curve about the x-axis. You integrate, what you will get is this region. You will get this region, right? And when you integrate the line from this point to this point, you will get this whole region, that is the trapezium. You will get the area for the trapezium. Now that trapezium's area is bigger than what is required here. Now this is the bounded region. So bounded region will be equal to the trapezium minus the curves under the curve region, right? That's much more simpler, right? Now let us find out. Already we know that this point is going to be. Now we do not actually we have not calculated what this point is. We just drew this line, right? Now we have to find out what this point is and what this point is. So we will do. How do you find the points of intersection of any two curves? What you have to do is simply just solve the equations. So you have x square equals 4y and x equals 4y minus 2. Just you solve this. So x equals this. Now I will substitute this here. So I will get 4y. Now another thing, when I am solving this, I must tell you this. When I am solving this, I should concentrate to save the time. I must concentrate on that variable which is required. I am going to take about x-axis, so x value is more important for me, so I will eliminate y. So what I will do is, from this equation I will write y equals x square by 4, and I will substitute that here. So I get x equals 4 into x square by 4 minus 2, which is x square minus 2. So I have x square minus x minus 2 equals 0, which is x square minus, this is minus 2, so minus 2 into plus 1 will give me minus 1. So I write minus 2x, splitting the middle term that I am using. So minus 2x plus x minus 2 equal to 0. So I am solving this equation by splitting the term, splitting the middle term, that is fraction, factorizing method. So x into x minus 2 plus 1 into x minus 2. So that gives me x minus 2 and x plus 1 equal to 0, which implies that x is equal to minus 1 and x is equal to 2. So these are the 2 points where it is cutting. So fortunately we are not fortunately, we have drawn it to the scale, so therefore we can exactly see that this is minus 1 here and this is cutting at x equals 2. So these are the 2 points, so about which we have to find the area. Now let us find the area. You can pause the video, you can try doing it, right? Because you know how to do it. So let us together do it. So here I have tried to write. I hope you would have written. You have paused the video and you are doing it. So you might have done exactly the same thing that we discussed. That is, integration of the line from minus 1 to 2 and subtract the curve's area, below the curve area from the line area. That is, the line area is going to be trapezium. Now what is the line because we have to write it in terms of x, we are integrating it with respect to x, so this line should be in terms of x. So y equals x plus 2 divided by 4, so 1 by 4 x plus 2 by 4, that is the y for the line, and the curve is y equals x square by 4. So we have written that, and we now solve this and we get the value. Please pause the video and just try to solve this further. I am also solving it. When I solve it further, I get this. What I could have done is, 1 by 4 could have been taken out and we could have written x plus 2. So you can, different people do it in different ways. So you can do that. X plus 2, you can keep it inside. 1 by 4 you can take out. I have kept it inside and I have solved this. So when you have by 4, when you integrate, you have x square by 8 plus half x and minus 1 to 2, and this is x cube by 12 minus 1 to 2. When I solve this, I get all this, right? So here I get 4 by 8, so that becomes 1 by 2, and this is 1 by 2. So 1 by 2 plus 1 by 2 is 1 plus 1, 2. So that's why I have written 2 minus, this is 1 by 8, so minus 1 by 8. And this gives me 8 by 2 cube by 12 means 8 by 12. And minus 1 cube by 12 means minus 1 by 12, and here you have to get minus, because minus of FB, right? FB minus FA. So minus 1 by 12, that becomes plus 1 by 12. That is plus 1 by 12, so that is 9 by 12, minus 9 by 12. That's why I have written minus 9 by 12. And when I divide this, I get 3 by 4. Now this is the situation. Now what I will do is, for common denominator, I will multiply 2 over here, and I get 2, that is equal to 2 minus, this is minus 3 to the 6 minus minus 1 minus 6, that is minus 7 by 8, and that gives me 8 to the 16 minus 7, which is 9 by 8 square units. So this is the area of the region bounded within this, right? So that, with that, I end this part and the complete portion that is related to application of integrals. I have tried to be as elaborate as possible within these 4 videos. I hope it will be beneficial for you, even if you are you have begun just now. So just of course, I tell you that you have to take this as a side dish. Go through all these 4 videos and it will help you in some way. Thank you, and I will meet you in the other portion of this syllabus. Thank you very much. Please come back again to this channel